Let's see another question. 5-meter ladder. So here we have 5-meter ladder. Okay. Against a vertical wall. So here is wall and just ladder is placed associated with wall. And the base of the ladder is 3 meter from the wall. Here 3 meter is given the base length, okay, from wall, between wall and ladder. And draw and label the right angle triangle formed by the wall, ground and ladder. So here we have found we have to form a right angle triangle. Here our ladder is 5 meter, here base is 3 meter, ground and our vertical wall is we don't know. Okay, so you can see that in regular life here base, ground and vertical wall is of 90-degree angles. So here this is our 90-degree angle. Okay, and if we represent as ABC, then angle C is 90-degree and triangle ABC is right angle triangle. Okay, let's see part B. This is part A. Let's see part B. So use Pythagorean theorem to calculate how high the ladder reaches up the wall. So we have to find the length of this wall, that how ladder reaches high from the bottom part. So we use the Pythagorean formula, which is a relation between the sides of a right angle triangle, which is a square plus b square is equal to c square. If triangle sides are a, b and c. Okay, so here a is not given, we have to find a. So we will just replace c square minus b square. Okay, then a is equal to under root c square minus b square. Okay, if we compare these two triangles, then c is 5 meter and our b is 3 meter. So we just put c as 5, so we will get 5 square minus 3 square. So it will be 25 minus 9. So it will be under root 16. So our A is 4 meter, right? So we have find B part. Then use part C. Use trigonometry to calculate the angle between the ladder and the ground. So here is our ladder of 5 meter and here base is 3 meter and we have found a wall of 4 meter. Okay, so to find the angle between ladder L and between ground. So here this angle we have to find this angle. Okay, we know one thing about a right angle triangle, that this edge or side is called hypotenuse, right? And this side is called adjacent side and this side is called opposite side. Okay, and one relation is derived in trigonometry, that the relation of these sides and between sine, cos and tan function. Okay, so if this angle is theta, suppose this angle is theta, then sine theta will be opposite side between adjacent side, right? Similarly, we know the formula of cos theta, or you will learn in mathematics or mathematics then cos theta is equal to adjacent side divided by, here we committed a mistake. Here we have to take hypotenuse. Here also hypotenuse, right? So let's take cos theta. So cos theta is equal to adjacent side divided by hypotenuse. We know the adjacent side size is 3 meter divided by hypotenuse is 5. If you see, if you divide 3 by 5, then you will get 0.6 as an answer. And we know the angle relation. If theta is 60 degree, cos 60 degree is 1 by 2. And 1 by 2 is also equal to 0.5. So here you can see that cos 60 degree is 0.5 and we got cos theta as 0.6. So we don't need exact answer, we need only the nearest degree answer. So our answer will be theta is equal to 60 degree because 0.6 is nearer to 0.5. So we can say that the theta is 60 degree nearer answer. So last question is, explain how you would help student decide what is hypotenuse and which trigonometric ratio to use. Hypotenuse. First we need to understand hypotenuse role. Pythagorean described that a hypotenuse is a side which is exactly opposite to 90 degree angle. And here hypotenuse is not adjacent to a 90 degree angle. So hypotenuse is our this side. This side is called hypotenuse. Okay. So in our case, the hypotenuse is this a ladder. So our ladder is a hypotenuse. Okay. And which trigonometric ratio to use? So in previous question we discussed that this is a ratio, this is also a ratio, and one another ratio is left which is tan theta, which is equal to opposite side divided by adjacent side, or we can simply say that tan theta is equal to sin theta ratio divided by cos theta ratio. Okay, thank you.